Suppose white chocolate costs $4 per pound and milk chocolate costs $5 per pound. Let x be the number of pounds of white chocolate and y be the number of pounds of milk chocolate bought. Graph the region in the xy plane that represents all possible weight combinations of white and milk chocolate that can be bought for $20 or less. Let's first of all try to get a grasp of what the problem is asking for. Let's make a table of values. In our first column, we'll put a value of x. In the second column, we'll put a value of y. In our third column, we'll calculate the cost of the white chocolate. In the fourth column, we'll put the cost of the milk chocolate, and then in the last column, we'll put the total cost. Okay, so again, in the first column, we're going to put x, which is the number of pounds of white chocolate. In the second column, we're going to put y, the number of pounds of milk chocolate. In the third column, we're going to put the cost of the white chocolate. In the fourth column, the cost of the milk chocolate. And then in the last column, we'll put the total cost. So what are some possible combinations? Well, what if we decided that we wanted to buy as much white chocolate as possible, but we didn't want any milk chocolate at all? Well, since we didn't want any milk chocolate, we would put 0 in the y column. And then in the x column, we'd have to use the fact that white chocolate costs $4 per pound, and we don't want to spend more than $20. So if we take $20 and divide by $4, that gives us 5. And so that indicates that we could buy 5 pounds of white chocolate. So what would be the cost of the white chocolate? It would be 5 times 4, which is 20. What would be the cost of the milk chocolate? Well, we're not buying any, so that cost would be 0. And then the total cost would be 20 plus 0, which is 20. So one possible combination is 5 pounds of white chocolate and 0 pounds of milk chocolate. And the point that we would be able to plot in the xy plane would be the point 5, 0. Okay, to get another point, we might consider the scenario that we want to buy all milk chocolate and no white chocolate. So in that case, x would be 0. And we know that milk chocolate costs $5 per pound. So if we have $20 to spend, then we could buy up to 4 pounds of milk chocolate. So if we wanted the most amount possible, we put 4 for y, in which case the cost of the white chocolate would be 0. The cost of the milk chocolate would be 20. And when we add the two costs together, we end up with 20. So another possible xy combination is 0, 4. So let's plot the point 0, 4 in the xy plane. All right, what would be a couple other combinations? Well, would it be possible to buy 2 pounds of white chocolate and 2 pounds of milk chocolate? Well, the cost of the white chocolate would be 2 times 4, which is 8. The cost of the the cost of the milk chocolate would be 2 times 5, which is 10. And then the total cost would be 8 plus 10, which is 18. And 18 is $20 or less, so that is one possible combination. So we could fill in or plot the point 2, 2 in the xy plane. Now if we had no craving for chocolate at all, I suppose we could say don't buy any white chocolate, don't buy any milk chocolate, in which case the cost of the white and milk chocolate would both be 0, and the total cost would be 0. So we could also have the point 0, 0. But notice there are some values of x and some values of y that don't make sense. It wouldn't make sense to buy a negative amount of white chocolate or a negative amount of milk chocolate. So all the points that we're going to plot are going to be in the first quadrant or on the positive x or positive y axis. Alright, well, we could continue this process and get many, many other points, but we want to plot all the possible weight combinations. So let's try to generalize. Alright, let's say that we have x pounds of white chocolate, y pounds of milk chocolate. What will be the cost of the white chocolate? Well, the white chocolate costs $4 per pound, so we need to multiply the number of pounds by 4, and when we multiply 4 by x, we get 4x. So 4x is the cost of the white chocolate. What would be the cost of the milk chocolate? Well, the milk chocolate costs $5 per pound, so we would take 5 times y, and that gives us 5y. What would be the total cost? Well, we need to add 4x plus 5y. So the total cost is 4x plus 5y. Now, what do we know about the total cost? We want the total cost to be $20 or less. So to indicate that, we can write an inequality. We can say that 4x plus 5y must be less than or equal to the number 20. So in order to plot all the possible weight combinations of white and milk chocolate, we want to graph 4x plus 5y is less than or equal to 20 in the first quadrant. So let's first of all find out what are the intercepts of this particular inequality. Or actually, if we write the associated equation would be 4x plus 5y is equal to 20. What are the x and y intercept of this particular equation? Well, when x is 0, which we've already done here, when x is 0, we see that the y value is 4. So 0, 4 is the y-intercept. What is the x-intercept? Well, the x-intercept occurs when y is 0. And we've already seen that when y is 0, the corresponding value of x is 5 if we want the total cost to be 20. So we have the point 5, 0. And then we can just draw the line that connects these 2 points. So we start at 0, 4, and then draw the line that goes down to the point 5, 0. Okay, we know that x and y both have to be non-negative, so x must be greater than or equal to 0, and y must also be greater than or equal to 0. So x greater than or equal to 0, we would find x equals 0, and for y greater than or equal to 0, we would draw a horizontal line segment from 0, 0 to 5, 0. And we want all the combinations where the cost will be $20 or less. Well, that will be all the points that are inside of the triangular region that we just drew. So we'll go ahead and shade in that region. Okay, it's all the points inside of that triangular region, and that represents all the possible weight combinations.